Hey guys, welcome to today's class. Have fun.
Longitude and latitude, and we'll be looking at the great cycle, the small cycle, the latitude, and then the longitude. Okay, when you hear small cycle, when you look at the globe, we have the equator, and then we have the what? The Greenwich meridian. Looking at the cycle that we have, the equator, which runs from the west to the east, is called the Great Cycle and has the longest distance across the globe, one of the longest distance across the globe. Then the smaller cycles are those ones above the equator, which is around the north and the south. This is the southern side, and then this is the northern side, and then this is the equator that divides the north and south. It runs from the west to the east and divides the north and south. So the smaller cycles are those ones that form cycle around the north and the and the south, where the great cycle is the equator. And then the latitude is an imaginary line used for the position of points on the earth's surface, and the latitude is normally represented in north and south. 30 degree north, 30 degrees, 25 degree north, 10 degree north, all those are latitude. When you see such, they are called latitude. While longitude are imaginary lines that cut through the center of the earth, joining the north and south pole. So these are lines of longitude, and they are represented with with west and east. We have 20 degree east, 25 degree east, 10 degree west. If you see such, is these are longitudes. Then when you see north, 10 degree north, 5 degree south, these are latitudes. So looking at the longitude, we have the line that runs at the center down that divides it is known as the Greenwich meridian. It is used as a standard form used to measure positions of other meridians in degree east or west. So this one is always 0 degree, and it's used as a standard to measure the positions of all other meridians in degree east or west. So straight up, we're going to the calculations, and coming to the calculations, we'll be calculating distances along the great cycles. I've told you the great cycle is that around the equator that runs from the west to the east. So I'll also be looking at distance along the parallel of latitude. So we'll take examples on that. So there is always a r, and that r is the radius of the bigger cycle, which is the equator, that divides the earth into north and south. And why the smaller r are those ones that form the latitudes, the northern area or the southern area, not around the equator. So those are the small r, and the relationship between the small r and the bigger r is r cos theta. R cos theta, small r equals to r cos theta. So theta is angle at at equator. So we take it example 1. So example 1 says P and Q are two places on the equator, and their longitudes are 173 degree east and 75 degree west respectively. So what is the shortest distance between them along the equator? How far is Q from From the south pole. So P and Q are two places at the equator. So looking at the diagram here, we have P and Q, which are 2 points around around the equator. So let's take our reference point to be this, which is 0 from here. So going to the east, you go like this, 10 degree, until you get to 90. Then 90, from 90 degree, you go until you reach the what? The 173, until you reach the 173 degree east. 173 degree east. So you go round until you reach the 173 degree what? East. Then coming from here, our reference point, which is what? Which is P. And come to this point, which is our reference point. This is Q, this is P, which is our reference point. So Q is 173 degree east. Is that so? No, Q is 75 degree west. So this is Q, 75 degree west, and then this is P. So we have P here. This was where the problem came from. So this, we have P, then we have Q. So the P is 173 degree east, whereas the Q is 75 degree what? West. So we took this as our reference point, which is 0. You go 90 degree east, then 173 degree east. Then coming here, 75 degrees, so it's less than 90. So we have our Q here, somewhere here. So one thing you must take note in longitude and latitude, the difference between two coordinates along the east, the difference between them will be you subtract. Or the difference between two coordinates around the west, the same coordinate is what? You subtract. But the difference between two positions in two different coordinates, what you do, you add. West east, you add. East west, the difference you add. Whereas the difference between two east, you what? You subtract. Understand? You get to understand that as we do our calculations. So now we are looking at the shortest distance between P and Q. Now if you look at this, the distance from here to here, just like I told us, you will add it. 75 plus 173 gives you what? 248, which is the distance from here to here. But this 248 is the longest distance between here and here, between P and Q. So the shortest distance now, angle at a point is what? 360. So you subtract 360 from 248 to get 112. So the distance for you to move from Q to P, the shortest distance from Q to P, or from P to Q, is around the what? Around the 112 degree, not the 248. The 248 is a longer distance. So we are asking us to find the distance along the shortest area. So the shortest distance will be gotten from the smallest what? Angle, which is 112. So PQ now is equals to what? We use our formula 2 pi r theta, where pi is 20/7 and r is 6,400. 6,400 is a constant. You can have that at the back of your head, but sometimes they do give us in mathematics what? Examinations. 22/7, pi is 22/7. So the shortest distance is 112/360 times 2 times 22/7 times 6,400, which gives you 12,515 kilometers. To two significant figure, this one significant figure, two significant figure, three significant figure, 4, 5. So two significant figure, it is what? 1,000. You take this one to this place, you give you 1,013 kilometers. So that's that. So the distance. So now we have to calculate Q's distance from the South Pole. Now looking at Q's distance from the South Pole, that means the distance from here, the distance of here from the South Pole is what? This is what we will have here to here, from here to here, from here to here. So that's the distance. And the angle at this point is 90 degree. Hope you understand. So the angle here is 90 degree. You have a straight line here, and you have what? This is a cycle. So you have a center here. You have another one. This is perpendicular to each other. It's a perpendicular. So this is a radius, and this is what? Another radius. So So the angle is 90 degree. So 90 over 360 times what? 2 pi r will give you the distance of Q from the South Pole. Understand? So why we use 2 pi r, we don't use small r, is because the radius here is what? Is the bigger radius we are using here. You understand? So we have 90 over 360, which gives you 1057. To two cylindrical figure, we have what? This one cylindrical figure, this the two cylindrical figure. So it gives you what? 1,000,000 kilometer to two cylindrical figure. So the next example, we are going to be calculating distance along what? Along the shorter what? Radius. So find the distance measured along the parallel of latitude between 2 points whose latitudes are both 56 degree north and whose longitudes are respectively 23 degree east and 17 degree west. So we have our equator, which is 0 degree, and we have our latitude, which is what? 56 degree north, and then we have our longitude, 73 degree west and 23 degree what? East. So looking at this, for you to get the angle from here, for distance from here to here, from A to B, we are now using what? The smaller r. This is the bigger r, but this is what? The smaller r. Understand? This is the bigger r, this is smaller r. So we are using the smaller r here, but the distance from here to here, to calculate the angle from here to here, you have to add, I told you there are two different coordinates, so you have to add them. 17 plus 23, so which gives you what? 40 degree. But the radius now which we are to use is the smaller r we are using here, but we have to convert the smaller r to a bigger radius, and the smaller r, the relationship between the small and the bigger r is r, which is equal to what? R cos theta. And our theta along the bigger r, the theta along the bigger r is looking at, to get the angle which is 56 degree from here to here is what? 53 degree from here to here. So the distance, the angle here from here to here is 56 degree, which is what? The angle of the bigger r. So which is what? 56 degrees. So we have 40 over 360 times 2 times 2 over 7 times 6,400, which is our constant r, the bigger r, times cos what? 56 degrees. Small r, you equate this into this, so you have what? 6,400 cos the theta, which is what? Of the bigger r, which is 56 degree. So when you calculate, use your calculator, you get 2499.50. So to two cylindrical figure, you have 2,500 kilometer. Hope you get it. If you have any question, you can leave it at the comment box. Thank you. I remain Amadi Solomon Chidebre.
I hope the class was interesting. If you have questions, please drop them in the comment section or send us an email. We will love to help you further. See you in the next class.